All right, folks. Today we are going to learn about a topic that has a strange name. It is called logarithms. So why do we care about logarithms? Well, we've been talking about exponential functions, and logarithms are very closely related. So here's one of the big problems that, well, first of all, let me show you something that maybe you can relate to. If we want to solve certain types of equations like 3x plus 7 equals 10, something like this, I think by now many of you folks already know the basics of solving this. You know the techniques. You subtract 7 from both sides, you divide by 3. You know how to get the answer to a problem like this. Some of you folks might recall how to get the answer to a problem that looks like maybe this. Maybe you might recall the techniques that are required. But what about if we have a problem that looks like this? What if we have something like 3x equals, well, if I make it really simple, then you'll know for sure. But let's make it so it's a little bit of a stretch, okay? It's a little bit trickier to figure out what x is in a problem like this. Now, it turns out there is, if these two numbers, 3 and 81, are very closely related, then it's not that big of a deal. Like, for instance, 81 is just 3 to the power of 4. So one way to solve a problem like this is simply to rewrite 81 as 3 to the power of 4. And if we do that, then we could say, well, if 3 to the x equals 3 to the 4, then x probably equals 4. So that's not so bad. But there is a bigger issue. And the bigger issue goes something like this. Okay, but what happens if we have a problem that looks like this? 2 to the power of x equals 7. Okay. Well, it's not entirely obvious what power of 2 7 is. In fact, 7 doesn't look like a power of 2 at all. If you think about it, 2 to the second power is 4, and 2 to the third power is 8. We just skipped right over 7. But it turns out, like so many cool things in math class, there's stuff you didn't know. You can raise a number to a power that is a fraction or a decimal. Well, actually, we did talk about raising a number to a fractional power, but we didn't talk about raising a number to a decimal, and we can do that. We can actually do both. So the thing is this: we'd like to have a way to get the x all by itself. And in this case, it's not obvious how to do it. So we need a new technique. Guess what? It's called logarithms. So here's how we're going to do it. What we're going to do is we're going to convert this exponential equation, and this is an exponential equation, into a logarithmic equation. And when we do that, we will magically get the x all by itself. Now, I'm going to show you how to do the conversion, and then we're going to talk about why it works and that kind of thing. We'll try to look at it from several perspectives. So first thing I'm going to do is I'm going to rewrite this guy as something like log base 2 of 7 equals x. Okay, so that's the concept of how you can rewrite an exponential as a log. Now, it shouldn't make a whole lot of sense to you right now, but basically what we'll do is anytime we have an exponential and we want to get the exponent by itself, we'll convert it to a log. And there's a procedure. Now, there are two different ways to think about the procedure. Some people sort of memorize the procedure, and some people try to understand why the logarithmic equation is similar to the exponential equation. In other words, how are they similar? What is the relationship between the two equations? So first, I'm going to show you the procedure. What I do something, I call it the Weingarten whirl. And it goes something like this. We go from the 2 to the 7, and then we go from the 7 to the x. And that is what we'll do. As long as the exponential is on the left and the numbers on the right, that's what we'll do to convert exponential equations into logs. We'll start with the 2, and then we'll go to the 7, and then go to the x. And you'll notice here's the little 2, and then here's the 7, and then here's the x. As we go from left to right, you can see 2, 7x. That was the procedure we followed. Now, why is the 2 small here and the 7 bigger and the x over there? Whole nother situation, whole nother question. One thing that might be helpful to us is to maybe consider, why is it what are the different names of the different parts? The good news is you guys already know the name of the 2. The 2 has a name that you already know. Maybe you could think about it for a minute. Pause the video. Okay, I'm going to go ahead and spoiler alert, here it comes. The 2 is known as the base. Whenever we have a power, we'll have a base. And then you definitely will know the name of the x. You know what the x is called, right? It is the exponent. And that is still true today. So maybe you knew that the 2 is called the base, and hopefully you definitely knew that the x is called the exponent. What about the 7? The 7 is a little bit trickier. What I say is, when the 7 is over here in the logarithm, I actually call the 7 the argument of the log. And we will use this idea of an argument in other types of math. So for example, I'm just going to write this off to the side. If we have something like the sine of 30 degrees, maybe at some point in your math career you saw something like sine, you saw trigonometry, maybe sine, cosine, tan. This 30 degrees would be the argument of the sine. In other words, whatever the function is acting on, in this case the sine function, we call it the argument. And in this case, this is a log function and it's acting on the 7, so we call it the argument. Now, those are not great reasons to call it the argument, but typically people refer to the 7 or the 30 degrees as an argument. Now forget about the sine for now. That's another unit of math. Okay, so what do we call the other stuff? Well, the 2 is, this little 2 is still called the base when we look at the logarithm. And what do we call this x? Oh, hey, I know what we can call the x. We can call it the exponent, because it is. Now, it doesn't look like an exponent here, but when you look, if we convert this log back to an exponential, it is the exponent. Now, there's something very interesting about the fact that the x is the exponent. And what is so interesting about that is that if log base 2 of 7 is equal to x, then this log, which I pronounced log base 2 of 7, this log must also be the exponent. I know, it's a little mind-blowing. This is some pretty advanced stuff. The good news is we're going to practice it a few times, and you guys are going to nail down how to convert back and forth. And once you get a hang of that, you will get a little bit of a sense how to calculate logs in your own head. And then we can back up and try to revisit these concepts and make sure you understand why the two things are related. Okay. All right. So what I like to do is I like to make a table and convert back and forth. So that's what we're going to do. So we're going to make a table. And in this table, on one side of the table, we're going to have expressions that are written in exponential form. And on the other side of the table, we will have expressions that are written in log form. So here we go. So we already know 2x equals 7 can be written like this. Let's try another one that we know. We know, for example, this time we'll do it with just numbers. We know that 5 to the power of 2 equals 25. And we're going to go ahead and rewrite that as a logarithm. So we can rewrite that as log base 5. Notice that I'm writing the 5 smaller than the log and a little bit below it. That's important. If you ever see logs printed in textbooks or in computers and such, they're written with a small. It's known. The 5 is known as the subscript. And so we do log base 5 of 25 is equal to 2. Which is the exponent. And all I'm doing is following this procedure here. I'm just doing the Weingarten whirl. I'm going from the 5 to the 25 to the 2. Log 5, 25, 2. Just so happens the 5 needs to be little and below, and then we need to put an equal sign. By the way, the 25 should not be written as an exponent, and the same with the 7. The 7 should not be written as an exponent. In other words, if I was to write these logs out without the little base, I would be writing, like, let's say we write log, let's say it's of 37. The 37 should be, the bottom of these guys should be at the same line. Okay, now I'm not obviously my writing is not perfect here, but this 37 should not be up high. And that 7 should not be up high. That 7, the bottom of the 7 and the bottom of the word log, they should be on the same line. Okay, and the bottom of the 25 and the bottom of the word log, they should be on the same line. Okay, so anyways, let's continue. So let's go and try. Let's try starting with a log, and we'll go backwards to exponential. So we're going to try something like log base 7 of 49 equals 2. In other words, if by the way, I want to point something out. If log base 7 of 49 is the exponent, what is it the exponent of? It's the log base 7 of 49 is the exponent of 7 that gets us 49. Okay, so we're going to do the Weingarten whirl backwards here in order to get to exponential form. We're going to go from the little 7 to the 2 and then to the 49, and that'll get us back to our exponential form. So, so we're going to say 7 to the power of 2 equals 49. So it's kind of important to be able to go back and forth and rewrite exponentials in log form or logs in exponential form. And if we can, then I'll show you some really cool stuff we can do that's kind of tricky. Okay, so let's try it again. Let's try let's try something fancy, a fancier power, a fancier exponent, because we've been learning about negative exponents and fractional exponents, so let's try them. So let's say we have something like 9 raised to the power of 1/2. That should equal, what is it? What is it? Spoiler, here it comes. That should be equal to 3. Square root of 9 is 3, and 9 to the 1/2 means 3. So if we want to write the log, it'll be log base 9 of 3 equals the exponent 1/2. Okay, and okay, so I'll leave that at that. Let's also try one with a negative exponent. So we're going to do something like, what about maybe 6 to the power of negative 2? That will be 1 over 36, well, also known as 1 over 6 squared. And let's go ahead and write that. So that'll be log base 6. This is the base 6, so I write it as a little base here. 1 over 36. The bottom of the 36 should be written at the bottom of the word log. So the argument is 1 over 36. And then that is equal to the exponent, which is negative 2. There we go. Sorry, that's an equal sign. Can I fix that? Can I fix that easily? No, I cannot. My eraser is huge. Why did they make the eraser so big? Oh well, okay. So next thing is, now I want to try something interesting. We're going to start with the log this time, and I want you to see if you can predict what it's going to be equal to. So what if I say something like log base 2 of 8, okay? This time, I'm not going to tell you what it's equal to. So now the goal is not even to rewrite an exponential form. The goal is to simply figure out, can I figure out in my head, can I be a human calculator and determine what is the log base 2 of 8? Okay. I'd like you to pause the video and see if you can write what this is equal to. In other words, you're going to write equal, and then you're going to write some number. Okay, I'm hoping that you paused the video, and I'm hoping you gave it some thought. And I am suspicious that some of you may have written something like 4, possibly, because 8 divided by 2 is 4, but that's not correct. The correct answer should be whatever power of 2 gets me 8. because log base 2 of 8 is the power of 2 that gets me 8. That's how logarithms work. So the correct answer should be 3. And then we can rewrite this as an exponential by going doing the Weingarten rule, 2 to 3 to 8. It'll be 2 to the power of 3 equals 8. Okay, now I'm going to try another one because I'm hoping that you're getting this. So this time I'm going to try, what if I put, let's try 81 here, and then I'm going to put 9 here, and then I'm going to say equals. Okay, now I'm making it a little tricky because I want you to have to work for this one. Even though I showed you how to do it over here, I'm going to make this one a little trickier. You got to put several pieces together. Pause the video, see if you can get it. Okay, I'm hopeful that you got it. Again, the question that we ask ourselves is, what power of 81 gets us 9? And it's a weird question because you don't normally think of raising 81 to some power to get a smaller number. But the answer is, drum roll please, 1/2. Because as we said earlier, a power of 1/2 means take the square root. So 81 to the 1/2 power will be 9. 81 to the 1/2 power equals 9. Okay. Your goal for today's lesson is to follow along, try to understand as best you can, take good notes, take a photo of the notes, submit it to this assignment, and then have a fantastic weekend. All right, folks. Take care.